In the last video, we wrote equations for a sine graph, and this one we're going to write it for a cosine graph. Remembering that when you're given a graph, you can always write it as sine or cosine. So if the question on the test does not specify which one you have to do, you can do the one that you're most comfortable with for that graph that's given. But on this one, we have to use cos. So we're looking to fill out this equation here, cos k. So the first thing that we always start with is our equation of the curve, which is also our q value. So if we go through the equation of the curve exactly halfway, 3 plus 1 is 4, divided by 2 equals 2. So that's where my equation of the curve hits. Then that helps me to easily find amplitude, my height of my peak and my height of my trough. So my amplitude is 1, but I know that my amplitude here must be negative because my cosine graph normally looks like this. My cosine graph normally starts high, comes low, and goes back up. So if it's been reflected in the x-axis, flipped upside down, it must have a negative a value. After that, I look for my phase shift. My phase shift normally would start here at x equals 0 on the y-axis. So in this case here, it must have been moved over 135 degrees. So we have negative 135 degrees. And last but not least, we have to look at our k value. We have to see the length of the cycle to see whether there was a compression or stretch at all. So if it started here at 135 and ended here at 225, we still have, at 225, 360 degrees in that cycle. So there was no change at all because it started at 360 degrees. So my k value remains as 1. So we now have enough information that we can substitute into our equation here. So we have negative cos. Our k value is 1, so we don't have to worry about it. Theta plus 135 plus 2 degrees. So if you're writing it as a cos graph, it's still the exact same method as doing it for sine. Always start by organizing yourself with your P, Q, A, K down the side. Here's the last example we're going to look at. We're going to determine the equation of a sinusoidal function, and right now it doesn't specify. We can write this as a sine theta expression or a cos theta expression. But what it has to have is a maximum point at 90 and 4 and a minimum at 180 and 1. The first thing that you must do is start with a sketch. Get a visual for yourself of what's happening. So we have 90, so that must be 45, 135, 180, 270. So we've started a graph, 1, 2, 3, 4. It doesn't have to be perfect, but enough to get you a picture of what's going on. So 90 and 4 is the first point, and 180 and 1 is my lowest point. So I start to connect these two, and I know that everything is always symmetrical. So it must go back up there. All of our graphs, whether you see it as a sine theta graph or a cos theta graph, can be divided into 4 equal parts. So if it took 90 degrees here, then it's also going to be 90 degrees on this side. So when I have this visual here, I see for myself, the easiest thing to do is write a cos theta expression. So I figure out my very first thing, always the equation of the curve. So my highest point is 4. My lowest point is 1. 4 plus 1 divided by 2 gives me 2.5. So my equation of the curve happens at 2.5. So my amplitude from 2.5 to 1 is 1.5 units, and it opens up so it stays positive. I investigate my phase shift. My phase shift for a cos graph would have started here on the y-axis. So it's moved over 90 degrees to the right. And last but not least, I need to see whether there is a compression or stretch horizontally. How long is my cycle? So my cycle started at 90 and ended at 270 degrees. So that means my cycle is only 180 degrees in length. So my K value must be 2. So I can come back up and have enough information to write my final answer here. 1.5 cos 2 theta minus 90 plus 2.5. And that's it. Done. Tomorrow we have more examples of this to do in class, and I will give you a handout to practice it.